Hello there and welcome to Lower 6th Further Maths A. This is the course part of the syllabus on the sample assessment material. Part A is to draw the set of points on the argand diagram that defines this long complicated bit of algebra here. So let's just ignore that bit. Let's ignore this bit here, let's ignore this bit here. This means it's going to be the intersection of both of these points. That's all I need from that bit. And let's ignore that bit here. So what I'm drawing is this part here and this part here. So, big clear diagram. So it's going to start at the opposite of this minus 4i, which is 4i. And it's going to be less than 3. So 1 is going to be down here, 7 is going to be up here, on the x-axis it's going to be 3 and 3, and seeing as it's just less than 3, I'll dot my lines going round. Alright, next point, z, so it's the opposite of this, so it's going to be plus 3i, so it's going to be here, and it's going to be minus 4i, so it's going to be exactly where we have the edge of our circle at here, and the radians is going to be from minus pi. Now we always remember that the starting point for a argument is at the positive x-axis, positive real axis. So if it's minus 2 pi, it's going downwards at a right angle of pi by 2. So it's going to be down here. Obviously you'd be using a ruler here, and it's dotted because it's not equal to it. And it's all the way up to pi by 4, which is going to be at a 45-degree angle, which should intersect the top of this circle as well. So it's going to be like this. So it's the intersection between this argument round from here to here and inside that circle, so this shaded part is this bit here. Okay, part B is complex number w satisfies w minus 4i equals 3. Find the maximum value of the argument, given your answer to 2 correct places. Now, this bit here looks a bit complicated. All this bit here is not a coordinate with just different brackets. It's just referring to the fact that you all know that the argument of a complex number can be represented from minus pi down to pi, and if it is on that negative axis, we say that it has an argument of pi. So don't get confused by that bit. Right, so let's draw a diagram. Always draw the diagram. And if it's got w minus 4i, then it's going to have a centre of circle at 4i and a radius of 3. So it's going to be something like this. So find the maximum value of the argument of w. So just the argument of w means it will start at 0, and if w is any point on this circle here, then the point at which it has a maximum argument is this point here. So what we're going to do here is measure this angle round from here to here. So what I'm going to do then is we'll say that this length from here to here has a radius of 3, because its circle has a radius of 3. The distance from here to here has a length of 4, because it's 4i as a coordinate. And this part here and here is definitely going to be at a right angle because it's a tangent touching a circle. So what we effectively have here, let's redraw this, is a triangle with a height of 3, an angle that we would like to know potentially here, let's call it alpha, so down there, and a hypotenuse of 4. So this is therefore going to be definitely a sine minus 1 equals opposite over hypotenuse 3 over 4. And add on the 90-degree angle there. So it's going to be pi by 2, add sine minus 1 of 3 over 4, which is going to be 2.42 radians. So that's the maximum value of arg of W. Okay, pictures with arguments and loci are always absolutely essential. I really suggest you always draw a clear diagram and try and work it out using right-angled triangles wherever you can. Use those coordinates or complex numbers to help you as well. Okay, 6 marks. No, 8 marks, sorry.